This single equation determines who gets a PhD at Harvard.
3 derivatives? I'm out. My brain hurts just looking at it.
Wait, you can solve this with one magic guess. Meet the rubber band of calculus, e to the rx.
Why is it a rubber band?
Stretch it, and it stays the same. It just spits out an R every time. Now plug this rubber band into our scary equation.
Whoa, the e to the rx is everywhere.
Since e to the rx is never zero, it's a stubborn balloon. We can just let it float away. Now it's just algebra.
Okay, I can do algebra. First 2 terms match, last 2 match.
Pull out the r minus 1.
And r squared minus 1 is difference of squares.
Exactly. So what are our magic numbers?
Easy, so we just plug them into the rubber band formula.
Buzz, wrong.
Why? Those correspond to the roots.
You just collapsed 2 building blocks into one. We need 3 distinct pieces.
So what do I do to keep them separate?
If you have a twin, you gotta wear a hat to look different. Multiply by x.
The x is the hat. Got it. Now we have 3 independent solutions.
We have our instructions: start at 0, velocity 0, and acceleration 1.
Let's apply these conditions to find our constants.
Careful with the derivative of x e to the x. We need the product rule. Now we evaluate everything at x equals 0.
Look, equation 1 says C1 plus C3 equals 0. That's a huge shortcut.
We can group C1 and C3 together in equation 3. Substitute 0, and equation 3 simplifies to 2C2 equals 1.
So C2 is definitely 1/2. 1 down, 2 to go.
Now substitute C2 into equation 2 to get a relation for C1 and C3.
We have a simple 2 times 2 system now. Solving these gives C1 equals -1/4 and C3 equals 1/4.
Let's plug them back into the general solution.
Harvard qualifying exam? More like Harvard qualifying easy.
Don't get cocky. There are much harder ones coming up.